First, you find the partial derivative of f of x with respect to x, which is 6x squared minus 6xy minus 24x. And you find the partial derivative with respect to y. So this is 0. This is 0. And then you get 3x squared negative minus 6y. After that, you get the points by using the first partial derivative. By using 6x squared minus 6xy minus 24x. Then you get x by setting y to 0. So you 6x squared set y to 0 minus 6x for x. When you factor out the 6, and x squared minus x. This is 0 minus 4. You will get x squared minus 4. Factor out an x. And you will get x equals 4. To get the y, you must substitute x to the second partial derivative with respect to y. You will get 3, negative 3, 4 squared minus 6y. And you will have negative 4 times 4 equals 16. 6y. 3 times 16. 3 times 16. 2 times 16 is equal to 32. 32 plus 16 is equal to 48. Negative 48. Negative 6y. Then you transfer 6y equal to negative 48. Divide both sides by 6. And then you will get y equals negative 8. Next, we will get the fxx. Foy fxy. Fxx is the second partial derivative with respect to x. So you can get 12x minus 6y minus 24 of fxx. We substitute 4 to x. 4 minus 6 y is negative 8 minus 24. After that, you will get the value of fxx, which is 72. Y and fxy, you will get negative 6 and negative 6x. D, we use fxx and multiply to fyy minus fxy squared. After multiplying, we get 72x, negative 36y, negative 144, negative 36x squared. You substitute the values of x and y. 72 times 4, negative 36 times negative 8, negative 144, negative 36, and then multiply the 4 squared. Get the value of d, which is 144. Now, since the value of our fxx is greater than 0, which is 72, but the value of our d is less than 0, therefore we have a saddle point. And that is all. Thank you for watching.
So this problem is about getting its directional derivative and finding if its value is in minimum or maximum. So to start off, we're gonna get the partial derivative of f of x and f of y. To get the partial derivative, we're gonna treat the y variable as a constant for f of x. So x squared is going to be 2x, negative 2 is going to be negative 2, and since there's no x variable attached to these y variables, that's just going to be 0. And then here we can see that y is attached to an x variable, so we're just going to bring it down. So positive derivative of 2x is 2, and we bring down y. Now, same thing goes for f of y. So we're going to start here. That's going to be 4y minus 2. And then positive 2x. Now, to get the critical points, I kind of forgot how we call this technique, but it's where you choose, I'm going to choose the partial derivative of f of y, which is 4y, negative 2 plus 2x. And then we're gonna convert it to a standard form. So let me just arrange that. It's gonna be 2x minus 4y minus 2. Then I'm gonna plug in values that would cancel 4y. So it's gonna be positive 4y over here, and then positive 4 over here, then negative 4x over here. Then just gonna continue solving it. So positive 4, negative 2, that would be positive 2. This would cancel. And then negative 4x and 2x would be negative 2x. Now, to get the x value of our critical point, I'm going to transfer our negative 2x over here. So it's going to be positive 2x equals positive 2. Then we're going to divide that by 2. This will get cancelled. So x equals 1 since 2 over 2 is considered as 1. Now, in getting our y variable, I'm going to move down a bit here. Getting our y value I need, we're going to substitute our x value into this, into the standard form of our partial derivative in f of y. So it's going to be 2, 1 plus 4y minus 2 equals 0. So 2 times 1 is 2 plus 4y minus 2 equals 0. So now 2 and minus 2 would be 0, leaving us with positive 4y equals 0. We're going to divide that by 4 to get our y value, so cancel that. So our y is equal to 0, since 0 divided by 4 equals 0. So our critical points would be critical points would be 1 and 0. Now, after getting our critical points, we're going to solve for fxx, fyy, and fxy. It's like a secondary move for like getting the partial derivative, like getting the partial derivative again. So fxx, fxy, my bad, fyy, and fxy. So first we're going to start with fxx. We're going to base it here on this partial, on the like first partial derivative of f of x that we got. So the partial derivative of this would be 2, since it's the only variable here that has an x. So continuing with fyy, that's only just going to be 4. Now getting the partial derivative of fxy, it would be this one, the positive 2xy. And its partial derivative is 2. Now we're going to solve for the directional derivative. So what's going to happen is that t would equal to this formula. So our fxx we multiplied with fyy and plus fxy. So that's the formula for getting the directional derivative. Then we're going to substitute this value. That would be 2 multiplied by 4 plus 2. Solve that. 4 times 2, that would be 8. Oh, wait, I forgot about, there's going to be like a 2 over there. So, yeah. So 2 times 4, that would be 8. And then plus 2 times 2, that would be 4. Oh wait, this is minus, my bad. I'm not really in a good headspace right now, but yeah. So 2 times 2, that would be 4. So t would equal to 4. So in determining if it's in like a local minimum or maximum, if d is greater than 0 and your f of xx is positive, that means it is in minimum. So with that said, this problem is in minimum. So thank you.
Our problem number 2 is f x of y is equals to x squared plus 4y squared minus 2x plus 8y. And our constraint is x plus 2y equals to 7. So first, we should find the partial derivative of this. So for f of x, the partial derivative is, since we're looking for the derivative of x, so x squared, so the derivative of that is 2x and this minus 2. And for f of y, the derivative of 4y squared is 8y plus 8. And in constraint, the derivative for g of x is x, so it is equivalent to 1. And for g of y, this 2. Now we are using the Lagrange formula, which is f x of y equals to lambda g x of y. So our f of x is equals to lambda g of x is 2x of o minus 2 is equals to lambda. And for our f of y equals to lambda g of y is 8 y of o plus 8 equals to lambda. So now we are solving equation with 3 unknown variable. So the first variable is this, the f of x. So first 2x of o minus 2 equals lambda. And our second is this 8 y sub o plus 8 equals to lambda. And our third unknown variable is the constraint, which is x plus 2y equals to 7. And now we are going to substitute the equation 2 by equation 1. So our second equation here is 8 y sub o plus 8 divided by 2, and our equation 1 is 2x sub o minus 2 divided by 2. So 8y sub o plus 8 divided by 2 is 4y sub o plus 4. And to this, 2x sub o minus 2 divided by 2 is 2x minus 2.
Good day everyone, I am Julito M. Sotillo, reporting about Lagrange multiplier. Also, this is the continuation of Marcos' explanation. 2x sub 0 minus 2 is equals to lambda. 8y sub 0 plus 8 is equals to 2 lambda. X sub 0 plus 2y sub 0 minus 7 is equals to 0. If you want to know where that equation came from, you need first to watch Marcos' report. And then proceed to the first. Solve the second equation and substitute it to the first. So we get 2x sub 0 minus 2 equals to 4y sub 0 plus 4. 2x sub 0 is equals to 4y sub 0 plus 2 plus 4. To get the x sub 0, is we need to divide the 2x sub 0 is equals to 4y sub 0 plus 6 to 2. So the answer is x sub 0 is equals to 4y sub 0 plus 3. And then substitute the answer to the third equation. So we get 2y sub 0 plus 3 plus an open parenthesis plus 2y sub 0 minus 7 is equals to 0. 4y sub 0 minus 4 is the answer. So so to find y, we need to divide 4y sub 0 is equals to 4 to divide to 4. So we get y sub 0 is equals to 1. To find the x value, we need to evaluate the first value of x. So we get x sub 0 is equals to 2 times 1 plus 3. The 1 is from the value of y. So the answer is x sub 0 is equals to 5, and that is the value of x. Thank you.
After getting the value of x and y, we evaluate the given x squared plus 4y squared minus 2x plus 8 at the point 5 and 1, 5 being x and y being y. So we substitute. We have 5 squared plus 4 times 1 squared minus 2 times 5 plus 8 times 1. So you have 25 plus 4 is 29. We have plus 8, you have 37, and minus 10, you have 27. So now we have the minimum value for x squared plus 4y squared minus 2x plus 8, which is 27.